Rebecca collects snow globes. When she was born, her grandma gave her 4 snow globes, and now it is a tradition. She gets 2 new ones each year on her birthday. This is a linear growth problem.
When she is first born, she has 4 snow globes. So the start value would be 4, and each year she gets 2 more. So the next now equation would be next equals now plus 2. The explicit equation is y equals 2x plus 4 because y equals the total number of snow globes overall, and 2x means 2 times the number of years, which represents x, and 4 is the start value because that's how many snow globes she started off with. Now we have to answer the question of how many snow globes will Rebecca have when she's 35 years old using our explicit rule. So since our equation is y equals 2x plus 4, and we have to find out how many she'll have when she's 35 years old, we plug in 35 as x for the number of years. 2 times 35 equals 70, and 70 plus the number of snow globes she had when she was born, which is 4, equals 74.
You and your research crew go to Africa to look at an increasing growth of a bird species since its predator has been hunted to extinction. The population has started at 160 birds and increases every month by doubling. The start is 160. For the next equals now rule, you get next equals now times 2. The explicit equation is y equals 160 times 2 to the x power. This is the graph. See how it is curved, meaning it is an exponential growth problem. You are a computer salesman/woman. You just got a new Apple computer installed. The starting price the first day is $69.99 and goes down by a rate of 5% each day. The explicit equation is y equals 69.99 times 0.95 to the power of x. You get 0.95 by subtracting 105 since it goes down by a rate of 5% each day. The recursive rule is next equals now times 0.95. The start is 69.99. It will cost $48.88 on the 7th day, but when it is the power of 0.95, 7th power, it is not a terminating decimal. So either way, you must round it at the end to 48.88.
Rebecca was born with 20 polka dots on her skin. The surgery to remove them is very dangerous, so she can only remove 2 a year. As you can see, this is a linear decay problem because every year it subtracts by 2. You can see that the graph is declining, so that means it's a linear decay problem. Your equation would be y equals negative 2x plus 20. Y represents the number of polka dots left. Negative 2 means that you remove 2 each year. X is the number of years, and plus 20 because that's the starting value. Our question is, how many years will it take to remove all of the polka dots? If you look at our graph and table, it says 0 polka dots around the 10-year mark. So let's try to plug in 10 as x and see if it gets us to 0. So negative 2 times 10 equals negative 20, and negative 20 plus the start value of 20 equals 0, even though it looks like a 6. So that means it takes 10 years to remove all of the polka dots. Our next question is, how many years will it take to remove half of the polka dots? Half of 20 would be 10, so we want to plug in 10 for y. You subtract 20 from this side, so it evens out. 10 minus 20 equals negative 10, so now you have negative 10 equals negative 2 times x. Now there's only the negative 2 left besides x, so we want to divide this by negative 2 and divide this by negative 2, and we get 5. So 5 equals x. So it will take 5 years to remove half of the polka dots, and it will take 10 years to remove all the polka dots. Thank you for watching!